Yes, good evening, everyone. Welcome back at this series. Today we are going to talk about normalization in a database, but this lesson is going to be in bits. I realize sometimes when I make a long video, sometimes it becomes boring, or not boring. Pardon me, French. Sometimes we fail to follow up. Therefore, it's going to be in bits. Therefore, we are talking about normalization in database. Without any further ado, let us delve into this. Now, when we talk about normalization, this process is basically dealing with how we can minimize data redundancy in our tables. So someone is going to ask, what is data redundancy? This is basically the repetition of data in a table. You have your data in your table, but it's really repeating. So we always fight hard to reduce data repetition by using what we call normalization. Therefore, normalization removes anomaly in our tables, and we have three types of anomalies. That is insertion anomaly, updation anomaly, and deletion anomaly. Before you look into normalization, let us first take a look at what anomaly is. And we usually say in database, anomalies are caused by poor management of storing everything in the flat database. Like you lack of normalization in your data, then at the end of the day you have data redundancy and improper use of primary or foreign keys. Sometimes if you're not using these keys very well, it will result into anomalies. Therefore, normalization divides the larger table into small tables and links them using a relationship. Therefore, this is our table. This is our table, and as we have said, that normalization divides the larger table into small tables and links them. Therefore, this is a very big table before normalization. So at the end of the day, after normalization, you realize that this big table is divided into small tables. It will depend on which level of normalization you're going to end at. Therefore, we are going to divide this table into small tables. So when you move down here, we have our big table divided. After normalizing it, we have table 1, table 2. Yeah, we have table 1 and table 2. I'm not explaining about the normalization. Like, I'm not explaining what the 3 levels of normalization, 3 or 4, but I'm just giving you a hint on what will happen after normalizing your table at the end of the day. Therefore, we had a very big table, this table, and it had 6 columns. But then we move down, we divided this table into 2. So we were supposed to have three columns, maybe 3 or 2. But now when you look at these tables, you realize that the total columns of these tables, when you combine, they are more than They are more than 6 columns. What we did, we added another column, which is called the ID. And as we said, that normalization divides a bigger table into small tables and links them using a relationship. So we have linked the 2 tables, table 1 and table 2, using the course ID. Therefore, here in the first table, it was very big. If you're looking at this person, the first person, Adon, and you want to know Adon's course, you have to follow up and until you reach Adon's course and fuck out as well. But now after normalizing, you realize that when you're here at Adon and you want to see his course, you just come and check his course ID, and it's B115. When you go back here on table 2, you realize that course ID B115 is a course of BIT. So that's how we do we normalize in database. That's how we divide